Carol Little. I recognize some faces, and I think some faces are new. From the sign-up sheet, we may have people trickling in. That's fine. They're parking. They'll do whatever. I do want to start off that the latest thing that I've read is that kids' anxiety in math, they have absolute proof that it's starting as low as kindergarten and first grade, and there is a direct correlation to how their parents and usually their mothers feel about math. So you're here today, so you probably aren't the group that I need to be reaching. You need to have the confidence as a learner. It's not about the math, it's the confidence that you exude as a learner. Everybody can learn. So you're going to understand the first grade math, but your child is going to move on. When they even hit math that you don't understand, it's not a reason to be afraid of it or intimidated by it. It's just an acceptance that I need to be a learner. We need to make sure we're not passing along this anxiety to kids. And looking at the group, this is more of an American and Western phenomenon than worldwide. Asia doesn't seem to have it, so we need to take the lead and follow that idea that this is just one more thing I have to learn. So thank you. You guys at the beginning, again, you're probably not the ones I need to be reaching out to. I do want to remind you, we are going through, I don't know exactly, a 6 or 7 week course for your kids in 40 minutes, 50 minutes. Please don't get so excited about this learning that you go home and try to teach this all to your children tonight. Please let the teachers start the teaching of it. I know you are your children's first teachers, but if we could get this introduced in a manner that we know is appropriate and that we have you support it, it would be much better. It's just confusing when they hear things at home and then go back to school and see it in a completely different way. We appreciate those different ways. Those different ways are what helps a flexible mind. But at first grade, there are some patterns that we want to follow. And especially once they're understanding it, we do want those, quote, other ways coming in because that is good for them. But we'd appreciate that we kind of follow. We know from best practices that we're going in a very meaningful way. Everybody should have a packet on their desk, table, whatever. Quickly, I just want to show you, this is my email. You are welcome to email me at any time. You're welcome to drop by and see me. I could be moving this week. Right now I'm located right inside the lower elementary area, but the coordinators are being moved into the new admin office that just got, I believe it's okay today to start moving. So in a week or so I will be in the admin area near the office. I'm there. I'm usually in the classroom. I'm around. You can email me or just drop by. The second email address, which is pretty awful to type in, is where we keep these resources. There will be a copy of this strategy packet. There will be a copy of this strategy packet with answers. There will also be a copy of this session up there. For every session we do, we put them up on this math resources page. If you Google the ASD parent math resources, it should come up as opposed to trying to type. The other thing, the only little thing that might be a little bit confusing, oh, I see a typo. It's not to be unveiled soon, it is open now. It might come up under, the Live Binders is the host of it, so if it says Live Binders, you're at the right place. That's just the name of the site. The second page on this, I'm not going to go through now because I will be hitting it through, but this is your guide to go back. If you're not following the language, or you're probably going to follow it while you're with me, but just like a student 4 hours from now when you're alone, you might not remember it. So this is the vocabulary that we're using with your kids. Please, they are 6 years old, maybe 7 years old. There is some kid-friendly language that we're using in first grade that we do graduate them from as they get older. The one I'm going to mention is we talk about addition and subtraction sentences. As they get older, we will switch the language to equations, but right now that's just too abstract for them. So it's the idea that it's a whole thought. The rest of these we will go over throughout this packet. This is the unit where the kids really start understanding that ones and tens are different, that a 10 is a bundle of 10 ones, and that that's how our number system is set up. We don't get to hundreds, so the place values right now are ones and tens, but they start developing and seeing the patterns of how we can start adding by tens. So we start showing a lot of things. We start with things they can count and see that are real life. So we have grapes. So this is a number bond. You've seen them in smaller numbers where we could break apart a number into two parts. So this is a part, and a whole. It's a very important understanding in mathematics that numbers, all sorts of numbers, right now they are using number bonds in 5th grade with fractions to make them work. So it's a very important concept that they understand that numbers can be broken apart and put back together. So in this one, this is the unit where we start having them looking at 10. They may need to count that one 10, but they recognize that it's a unit of 10. So in this one, we have 20 grapes, we have 7 others, and that makes the number 27. We can start accepting that these are bundles of 10 and we don't have to count them each time. So we have 3 bundles of 10, which is 30, plus 2 more is 32. They are going to get multiple things of doing this, not just one. To begin with, when their pictures are realistic, we don't even have the counters out yet because we want them to understand that. We start moving towards the manipulatives next. So you'll see in the next picture, we've taken away the real life context and we're getting more to the abstract number. So we have 3 groups of 10. I don't even 1, 2, 3, 4, 5, 6, 7. We have them. We could count each one, but we start talking about the efficiency of it. Is it efficient to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 30, and then the 7 more? Or can we go 10, 20, 30, 31, 32, and up to 37? So we have 30 and 7, which equals a total or a whole group of 37. So these first 3 are really talking about the number itself. The 4th picture, all of a sudden, is actually introducing addition without any symbols, without any sentences, but we've broken those tens apart. So it's that idea. They don't have to be placed right next to each other to have the same value. So again, it's this flexibility of numbers. Can they count them without counting every individual one? Can they count 10, 20, 30? They're probably going to know 35 because they've been using 5 frames since pre-K. 36, 37, 38, 39. So what does that look like? I have a whole number of 39. It's grouped into 30 and 9. Making sense? In a week or 2 after first seeing this, they're then going to see this as 18 plus 21. But right now they're just seeing that they can move these around, numbers are flexible, and put the 10s together and put the 1s together because that's how our number system works. What could go wrong here is if a child isn't understanding this, I mean, I could make it up. They're either going to do 10, they're going to count this on and keep counting these as 1s. What we're looking at this point is, do they know that the 10s go together and the 1s go together? And that is a very large, that is a very important issue at this point. 10s go with 10s, 1s go with 1s, but we can break them apart or we can put things together to make them work for us. The next one is we then start showing them the place value chart. We start recording differently in a place value chart. How many groups do we have here? How many groups of 10 do we have? 3. So we are going to write down the 3 in the 10s place, not 30. It is 3 10s, and then we have 5 1s, and they start making that connection that that is how the number looks. And I would say this is where the math has changed a little. The math hasn't changed. This has always been equal. But asking kids to recognize that they can put it together and they can take it back apart is a strategy to be used. So we have 2 10s and 4 1s. But if those 2 necklaces were to break and the beads all fell onto the table, we would have 24 1s. And I would say this is a new emphasis in the last couple of years to keep this flexibility open of knowing that 2 10s and 4 1s is the same as 24 1s. It becomes very important when we get to subtraction and we're having to take things away, and that's where the regrouping comes from. If you turn to your partner, what else does this equal? It equals 2 10s and 4 1s. It equals 24 1s. What else does it equal? I have 2 10s and 4 1s. I could break these all apart and get my 24 1s. What else can I do? You know I'm going to want that 10 back. So what else do I have? Well, I have 14. What do I have in this picture? 110. I have 110 and 14 ones. So this number can be seen multiple ways. And that's that open-mindedness that we want, because I definitely was not taught that way. Once I had 24, that's all it was. So can we just go 27? How many 10s would that be? Why don't you just do the last 2 with your partners? I don't think it needs to be done with me. So at this point, they're always going to have the manipulatives on their table. They're going to have these to relate to and to talk to. But they're going to start learning how to use this place value to compare numbers and to add numbers. So at this point, the kids are going to move on to comparing numbers. And this is a classic greater than, less than, and equal to. I'd like to talk to you about equal to. Because in our equations or number sentences, we're not really using the word equals yet. Again, it's rather abstract for kids. We know that kids start thinking equals to means get the right answer. So we're using it as a balance. So 3 plus 4 is the same as 7. So in our number sentences, that's the language we're using. When we're talking about greater than, less than, and equal to, we are using equal because the numbers are there, and it's also the time that we can use it, but we will use both language. But this is the common language of mathematics, so at this point, this is where we're introducing it. We still use the same as to make sure they understand it, and this is where they get used to that language connecting to the equal sign. At first, they're looking at objects and they're just comparing the value of one object to the next. So we have carrots. How many carrots are there? 3. And we have crayons. How many are there? 25. So 34 is greater than 25. We work for quite a time with just the language. The kids honestly don't have a lot of trouble with the language. Where they have trouble is where we start introducing the sign. They understand the concept, they just can't remember which direction the sign goes. And so we help them with that. We also want them to prove this because really they could just guess. There's only 3 answers, and so they could guess. So we have a lot of them explaining their thinking. And this first one is the way that we would kind of expect them to prove their thinking. So this is 20. We have our word bank that is wonderfully yellow, mostly because I couldn't figure out how to get the yellow highlighting off. There's nothing important about this word bank other than it's there. So we're asking 20 is greater than or less than or equal to 18. If they're still not understanding the numbers, they've got the pictures up here. And so they should see that 20 is greater than 18. On the next one, I would expect proof. They're drawing 2 10s and they're drawing 3 10s. So 2 10s are less than 3 10s. Would you go ahead and prove to me the answer on the next one and see if your partner agrees? And this form of drawing is on your front page descriptor. It's called drawing quick 10s. But we don't, at this point, expect the kids to be drawing out 10 dots, that they can draw a line. And the circles or dots really don't matter. You'll see that we can use dots, we can use X's. They're just to represent the individual ones. So far, so good? And here comes the part that tricks them up. Now we associate the language with a symbol. Mathematicians, teachers of the world, have tried many different ways to get them just to learn. I promise you they understand the concept. It's which one is which. The alligator mouth is the thing that seems to have stuck. The alligator's hungry, so the mouth always wants to point to the larger number. I work with a lady who's world renowned, and she goes, "Oh, that's just stupid." And I sit there going, "Yeah, but that's how I remember it." It works. It's a story that helps us make that connection to which is which. It's not the only story. I know one other teacher always put more dots on the side that was the bigger number. So there's 2 dots here, so it would go to a bigger number. If I had 3 and 6, I put the 2 dots near the 6 and I draw it that way. This is simply about memorizing how to draw a symbol. The kids usually remember the concept. So they'll probably be talking about the alligator. If they're hungry, they want the bigger number. So would you go ahead and do A, B, and C? And I would like proof as to why. And this is where we start really connecting the language with the symbol. double check with your neighbor. So the greater than, less than, and equal to will be with us through 5th grade. Again, we do it with whole numbers. We will do it with hundreds. We will do it with thousands. We will do it with fractions. We will do it with decimals. So this is the beginning point of understanding, not only just understanding, but also proving that we're correct. So in this unit, they are, as I said, they're doing place value, they're doing comparison, and they are doing adding up to 40. The only subtraction in the unit is by tens. So I think we get on it a little bit, or unless it's down in the very, very small numbers that they've already done. But this is a heavily place value addition unit. So we're going to look at this. We're going to start off just by adding tens to other numbers. So it might be 10, it might be 20, but we're not adding 14 and 17 to begin with. So can they see the pattern of the place value? Can they start using our number system to understand and really do this? They will get to be doing it with mental math, that this is not really a write it down procedure once they understand it. To begin with, they're going to be building it, drawing it, and writing it. So our first one, we've got 19 plus 10. This is the beginning of a number bond. We have two parts, 19 and 10. How much does that equal? They would have added it up to find out that it's 29. And we really want them to see what happened in their final answer. Can they see the relationship? Oh, we put the tens together. We had one and another one, and we came up with 2. So that's why that place value box is there, is to connect that they can add tens and put it in the tens place. We'd expect the answer at the top. And the same thing happens if I have 20 and 14. The circles is my habit. I'm not quite sure whether your teachers will be asking for it. Probably. If they become a problem, kids want to draw the circle first and then they draw it so small that they can't write the answer in it, drop the circles. They're not the important part of this. I do it out of habit because that's the way a number bond usually looks. So 20 and 14, well, I have 2 tens and 1 10, so I'd have 3 tens and 4 ones. And I can see that in my place value. So I'm not only seeing it as 30 plus 4, but I'm seeing it as 3 tens and 4 ones. After some practice with this, and I'm going to remind you, we're going through a 6-7 week unit. They're doing this quite a bit, and we're doing 2 problems, or you're seeing 2 problems. We're introducing a notation called the arrow way. This, when we changed to the resource we're using, this was the biggest, loveliest thing I ever saw, because we have kids who do a lot of mental math, and we want that and we encourage that. And then we made them write it down this very laborious way that looks a lot like algebra, because mathematically that was the correct way to write it. The arrow notation really is a way to write down what you're thinking as you go along. So if I wanted to say 13, let's do 13 plus 23. In my head, I can do 13 plus 20 equals 33 plus, I forgot what I said. I said, oh, I need a better problem. Okay, 13 plus 23. Now I need to add 3 more, and I get 36. Most of us would have wanted to write equal signs there, which is absolutely incorrect mathematically, because we would have ended up with 13 equals 36, which is wrong. The arrow just says, this is what I'm doing. This is where I'm heading. I added 20, I added 3, and I added 30, and I got 36. This is not where we're at, but I wanted to show you why we're going there. So this is a notation. So for those kids who just say, oh, I just knew it, it's what I did in my head, we want to encourage that, because we used to say, no, write it down. Well, that didn't help us. So we're giving them this notation. So that's what this is about. So if it's 13 plus 10, I get to 23. If I have 19, how much do I need to add to get to 39? If I had something and I added 10 and I got to 27, what did I start with?
17.
And the same type, I had something, I added 20 and I got to 38. This really captures the way a lot of kids think. Because we're showing them how to do it by place value. We're asking them to be that, but I know I keep using that word, that flexibility. Now we're giving them a way to write it. This can be also 13 plus 19. We'll see kids do 13 plus 20. Yep. 13 plus 20 equals 33, but I added one too many, so I need to take away one, and it equals 32. So it's related to the number line, partially. So they can do anything they want. They're just showing us the way they got to it.
So you expect them to do that last one now in
No.
first grade, or?
No. But I can tell you, there are some kids who could do that. They wouldn't know how to write it, they could explain it verbally. This is giving them the way to write it down. And I mean, I'll speak for myself. I was never given the option to do that in school. I had to write down the whole thing. I had to regroup tens. I had to do all these things. Where it really is, if you can recognize it's only one number too high or one number too low, that is so much easier. So this whole idea of using our tens numbers, if we can get to what we call them a friendly number, we also call them benchmark numbers. They just make our life not only easier, it's more efficient, and it's usually more accurate.
I think so far it has been great seeing all these, how they go and flow with these numbers. But when I got to this arrow ways, I think this is a bit difficult for grade oneers. I think most of them, they might have difficulty because it doesn't flow normally as what you has explained before. Everything else you're teaching them, it's fine, it's flowing correctly. But when you hit this, I think it's going to be difficult.
Okay, so a couple different things. We offer a lot of strategies, and some of them are never going. There are going to be kids who will never use the arrow method. It just doesn't. That's not the way they click. They like to see it written down. I think you might be amazed at how many kids do like it, but they do have to practice. We kind of go, just because you can do your basketball straightforward, we teach you the layup. It takes a while before the layup becomes proficient. So yes, at the beginning it might be tough. They're doing this with a lot of scaffolding also, and yet we're at a beginning stage.
Yeah, because I don't understand the method. Is there a method to teach them how to do this? Because they're going to do this in their head, you said. Are you going to give them some tools?
Yes, they're welcome to. Yes, they would have manipulatives out on their thing the whole time. What really becomes useful is having this place value chart. Is where they see it. Is, oh, I'm just adding another 10, so it's 19. I could write it down as 19 plus 10. I could write it down as I'm thinking. Right now, I would agree that it feels a little artificial because these are so simple, but that's where we have to start. And that's why I was trying to show you that this is more of a reason to have it. Right now, this is just kind of copying, it's just another strategy for what we've already done. We offer it, we offer the practice, we don't require it of any child. We will talk about efficiency as we go along, and when I say as we go along, I mean more second and third grade. So right now, we're just at that beginning building stage. I've had several discussions. There are some things that we're doing now that teachers are less comfortable with than the children because we weren't shown it early. We're a little bit, although we're open to new ideas, we still kind of bring our learning, our past learning with us. I'll tell you from teachers, I've had more positive responses about this, but I'm sure there are individual children who this is not going to work for. And it's not about aptitude or smartness, it's just the way they think and the way they want to see it. It doesn't mean one way is better than the other. Yes?
Sorry, can you go back to the page? For example, if number 5, it's 19 plus 17. So the ones actually make another 10.
I'm sorry, I didn't catch where we're
So
looking.
for example, if it was 19 plus 17, number 5. For number 5, the first question.
Oh, yes.
So the ones actually make another 10. How can I approach this problem?
Okay, I'm seeing 19 plus 10.
Yeah, so what if it was
Oh,
17?
if it was 17. Okay, sorry, I'm trying to see. Let's talk about it. I promise it's on the next page. Exactly. This is particularly, this page was about only adding 10s or 20s. I mean, we wouldn't add 30s because, I mean, we're getting too high. Well, we could do 30 plus 9. It only goes up to 40. So these we are teaching them in a very particular order so that they can be ready for that. Because yes, that would be the hardest one that we're going to do. And what you're going to see is you've got these cubes in front of you. You're welcome to use them, but you don't have to. But we do start off with the cubes. We want them to see that this question of 22 plus 6 can be built. And they are seeing them in 2 different colors. Otherwise, I never regret taking that apart. So we have 26, no, we have 22. And then I build my 6. And where is it going to be added? It's going to be added into the ones place. So I can draw it. I have 22. I can count my 20 very quickly. 10, 20, 2. We're hoping that a child can add 2 plus 6 at this point, but if not, they can add on 22, 23, 24, 25, 26, 27, 28. So I get 28, and I made 2 10s and 8 1s. So we definitely start by building it and having the picture. As we get comfortable with that, we move to just drawing the picture, where we make the 24, the 2 quick 10s and the 4 dots, plus this other 3. This is where it's talking about dots or X's. We just want to see a difference. So what does that equal? Well, it's 2 10s and 7 1s. It equals 27. Trust me, number 3 is the same type. Can you go to number 4? We have 10, and then we have, oh, I shouldn't have written it that way. We have 10, 11, 12, 13, 14, 15, 16. And I have 1, 2, 3, 4. Here, they've been practicing since kindergarten. 10 1s equals 1 10. So I turn that into a quick 10. So I went from 16 plus 4. What do I have? I have 2 10s with 0 1s, which equals 20. So they know about bundling 10 1s together equals 110. It's called regrouping, it's called bundling. We don't test them on that language. We want them to be able to say that they go together and 10 1s equals 110. Does that make sense? Because what I really want to get to is there's regrouping up to 10. It's the following page that I think directly hits your question. So we've shown them how to build it, we've shown them how to draw it. Now we're starting to regroup. So again, I'm trying to support you to help your kids, so I'm showing you, if you see the work from school, this is what it's going to look like. So you could see that it was 10 and 5, so we started with 15. We added 5 more X's. We bundled that 10 together, so we get an answer of 2 10s, 0 1s, so our answer is 20. Would you do the next 2? Because I would like you, would you do this one? And I would like you to draw that one also. As I draw, I do my 28, I have to add on 4, I finish out my 10. And nowhere in here have I used the term I carry a 1. Just the way I was taught. Had no meaning, but I hate to say it, if you talk to most teachers, we were good memorizers. That's what we were asked to do. I could memorize that. I was never asked to explain it. I probably did intuitively understand it, but when we ask our kids to explain it, we know they understand it. But we just don't use that language anymore because it's not mathematically correct. They regroup 10 ones into a 10, not a 1, but we can use the language. They don't have to say a 10, because I understand as we're writing, it's 110. That's where the 1 comes from. So yes, I am physically writing down a 1 up there. Your kids will get to that, but probably not until about 3rd grade when it becomes efficient and we're using the column method more. The one little bit, not that you need to know, is we've started putting the 1 down at the bottom instead of the top. Basically, a lot of psychiatrists and psychologists told us the brain likes it better. It's right either way. We don't really care. Yeah?
Is it right, like, for instance, my daughter, if I asked her to add 27 plus 2, she said, I put 27 in my head, and I put 2 here, like 28, 29. Is it right? We used to do this when we were kids. Is it right to do it right now?
Yeah, and I would hope that she's going to do that numerous times and finally realize I don't really need to count the 2 on my fingers. I know that 7 and 2, especially as she's getting exposed to this. But absolutely, that is what she's doing. And the fact that she's doing that in her head and not demanding a piece of paper, which is what we used to make everybody do, that's exactly what we want them. Well, yeah. Okay, so these are more in the same. I think you understand. I am going to leave these blank. I will put the answers up on the site if you're a little worried. And you know what? I know it's not that you're worried about the answers. You're worried about the notation and wanting to do it right for your kids. So please, be my guest to look at. And I know it's not. I mean, we do that as teachers. It's like, well, I know what the answer is, but I want to make sure that I'm getting to the right strategy. Addition, subtraction, multiplication, and division is what is the crux of elementary teaching, and it's considered arithmetic. We're talking about, we call them naked numbers, they have no context, you get a right answer. The thinking is that's not really mathematics. In the real world, nobody hands you a whiteboard with an equation on it and says solve it. You get into a grocery store and you have to figure out what you're doing, and you have to figure that out. So we consider word problems in first grade problem solving. The fact that they can take a story and figure out what to do with it mathematically is a challenge. But it's the fun challenge. It's the real world, and this is actually what they need to be able to do. The other stuff is just the skills to be able to do the real mathematics. So if your child is struggling in English or struggling with reading, mathematics has just gotten hard for them. And we appreciate that, but if we take it away, then we're not teaching them what they really need to know in life. So what's really happened is 20 years ago, because of a lot of EAL, or English as a second language throughout the world, we got rid of all the word problems. And we really didn't do a great job of teaching those kids. We thought we were doing the right thing. So the word problems have come back. We're embracing them happily. So we're using the same strategies as the reading teacher. You need to have a mind movie with this. What is the action that's going on in the story? When you can see the action, you're going to figure out how to solve it. Then you can use your different strategies of how to add or subtract. But if you don't know what to do in this story, most kids grab two numbers and add until they get to fourth grade, then they grab two numbers and multiply. They disregard the story, and we know you can't do that. So, what we would ask the kids to do is close your eyes. Lee saw 6 squashes and 7 pumpkins growing in his garden. And immediately a hand's gonna go up going, I don't know what a squash is. Fine, he saw 6 tomatoes. Do you know what a tomato is? And do you know what pumpkins are? So we go through that. This is problem solving. How can we access this problem? So we saw 6 squashes and 7 pumpkins growing in his garden. How many vegetables did he see growing in the garden? If you can see that happening, I don't think there's anybody who's not going to know how to solve it. So we want to know that what they're seeing. So lovely, I'm going to do 6 squashes. I'm going to do 7 pumpkins. And I put them together in a line because I wanted to know how many. We're going to introduce them pretty much for the first time to a thing called the tape diagram. It's a way of explaining that you understand the question. So in a tape diagram, we put it in a rectangle. And we label it, this is squashes and this is pumpkins. You're labeling it so that somebody else knows what you know. So I'm not making them write out squashes and pumpkins. This is not meant to be torture. This is meant to be about communication. So now, there's lots of ways of solving this. I would expect to see 6 plus 7 so that we get our number sentence someplace. They could count, they could do 6, 7, 8, 9, 10, 11, 12, 13. They could do 6, 7, 8, 9, 10, bundle it into a 10, and see that they have 3 more, which of course is the same answer. They just used 2 different strategies of getting there. And so Lee saw 13 vegetables. This sentence is very important now because this is what makes you go back and figure out, am I actually answering the right question? Not so much on an addition problem, but on a subtraction problem, and as things get trickier as they go. So they will always be asked to draw some sort of representation so that we know they understand the problem. They need to solve it, and in this one I didn't need to do anything separate. I didn't need to because I used my drawing, and then I wrote the number sentence and the answer. This will be the expectation by the end of first grade. So we're practicing it and teaching it now. Kiana caught 6 lizards. His brother caught 6 snakes. How many reptiles do they have in all? It's going to be a very similar representation. They're going to label it and they're going to answer it. So now I want you to picture this. 9 dogs were playing at the park. Some more dogs came. Then there were 11 dogs. I'm sorry, I forgot something back here. Taking this back to our whole. Where was the question? We don't know the total. That's gonna make more sense here. So what do I know? I know there were 9 dogs. Some more came. Do I know how many? There's my question mark. So I have a part and a part. Do I know the whole? Yes, I know there were 11. So this is back to the number bond that we did with numbers. I'm hoping you're seeing how all these things start getting interrelated. So this is a part whole. I just know different information. Well, if I have 9 dogs, I can go, well, 9, 10, 11. So my question is 2.
Shouldn't they use the same, like, because it starts, it's not something else, not the cats, or because you're using X here?
But it's a different part.
Okay.
And we're not really going to care. The reason we use 2 different ones is because there's some kids' brains who really want to see the 2 different parts. I probably would, well, 1, I don't care. But 2, I would expect most kids to differentiate just by the parts. It's not because, yeah, I understand that they're different questions. It's more that they're different numbers. So on this, I'm going to expect most kids to do 9 plus 2 equals 11. But we need to know which is the number they solved for. So most teachers have them box it or circle it. So in the olden days, this was a subtraction problem. You can subtract here to solve it. You may solve this any way you want once you get the picture. It could have been 11 minus 9 equals 2. Absolutely correct. But we no longer call it, oh, this is a subtraction problem, because there are a lot of kids in the room who were adding up to find it, and they're right, and the teacher's standing at the front of the classroom saying, it's a subtraction problem. And their brain just went, what? But okay, I'm wrong, I don't get it. So we're no longer labeling these problems. I mean, addition, honestly, is always going to be addition, but there's no such thing as always subtraction. We're going to find out it's easier at times to subtract than to add up as they get more mature. But right now, a lot of them, this is a techie term, this is a missing addend problem, and most kids will add up. This would be generated from a child. They're not really going to be talking about it in this unit. Oh, it's going to come out. I shouldn't say it that way.
So you said you could do this also with the bonds. Is it preferably to teach them the tape diagram?
Yeah, this is us kind of starting to move away from the number bond. The number bond gets cumbersome. It's strangely enough, it's harder to label. And this tape diagram, they will be using through middle school, where the number bond doesn't work as easily for multiplication and division, where it starts being a way to hold information. Right now, they can use it to solve their problems, but as they move on, you would see other work in here. This represents that they know the question. Would you try number 5, please? I'm looking at the clock, and we'll do both 4 and 5. Do 5 first, just because I said so, and then I'll come back and I'll show you just the notation we probably expect from kids. was similar to number 3. The sum just came in a different place. But now that they're understanding its part, I can put a question mark, I know the other part, and I know the whole. I'm 30 seconds over, but I am going to do number 4 for you. If we have 16 strawberries, and Peter eats 8 of them, we're going to just mark through 8. So he had 16. In this case, he did take away 8. How many does he have left? 1, 2, 3, 4, 5, 6, 7, 8. For children who are seeing this easily, by the end of the year, they're probably not going to be drawing dots and X's, they're going to be putting the numbers in there. It means the same thing, they just move on to using the numbers as opposed to the symbol. Both are correct. To begin with, I'm going to want them to prove to me that they know it for a time or 2, but yes, I'm going to let them move on. So if a child sees that that's 9, question mark 11, I'm going to allow that. Please support the teacher. At the beginning though, I'm going to want them to prove it. And so I am going to be having them draw some pictures. And so the labeling that they asked for, that I would probably, well, I mean, that's as much as you're going to do. I guess you could write 8. I'm not sure that's important. The last page, as I've gone over here, really is just showing you these same concepts taken to larger numbers that we start breaking apart, because we will be adding 18 and 14. We've moved on from drawing, we moved on from building and drawing. Now we're paying attention to the place values and how we can add them. How can we break apart numbers to make it easy for us? So these are our number bonds. I know that 18 can be added to 10 and get 28, and I can add 28 plus 4 and get 32. It's up to the students eventually. They get to pick which number they want to break apart. It's usually the smaller number, not the first number, is usually how the decision is made. And then the last thing, I just put some other things on here. These are things you can do with your kids. This is that flexibility that we started with at the morning, that you could, or at the beginning. This is a great stoplight question. How many different ways can you make this number? Keeping that idea. The last page, if your children want some extension work, these are probably, well, they go by grade level. These are, how do I say this? We're extending their ideas of what math is, because a lot of kids think math are 2 numbers on a piece of paper. This is a lot of logic. There's one for art. There's one for, I think the Math Cats they have games. It's really seeing the mathematics. These are not more 3 plus 4 equals 7. They get enough of that. Can I ask you a question? How many of you are playing the games with your kids at home? The book? Yeah, there's a book that came home and they have, okay, we're just kind of curious because that was a different. Those are the games that really help you develop the math skills. These are more clever. They can help you. I mean, there's such a variety up here, but these have been vetted. I'm not seeing the one up there. Okay, yeah.
What do you think of the Google Maps app? It's been recommended by this teacher, and we do it at home.
I love
all the
it.
time. It's
Yeah.
really nice.
Yes, it really
has
is.
a lot of different ways.
It's an app for an iPad, I believe.
Yeah.
I'm not, if you want to look it up, it's Doodle. Yeah, it's really fun.
Yeah.
And again, anytime that kids are appreciating it, and it's colorful and it's clever, this is what we want them to think of math. Because really math is about problem solving, which is puzzles. And it's supposed to be an enjoyable thing. And you know what? You are supposed to struggle. If you're not struggling, you already know it, so you're not learning anything. Now, there's a fine line of going too far. The very last one is Greenbox. This costs, I don't know, $12 to $15, possibly a month. I have never used it, but we have a new tech person in Lower L, and she said it's excellent. You could go on and you could get a free, not a free for a month, you could get a trial to try it. So I can say that it comes highly recommended, but I haven't actually tried it. They keep signing up for the free trial and then not getting back to it within my 30 days. So if you want more time, I'm also going to say the research is not coming out in favor of a lot of homework. Your child should be reading every night. You should be talking about math and stuff. If they are having trouble with math facts, those games are what we should be doing, and that is the best use of their time. But sometimes they want more, and we want to be able to hand them more. If they're asking for it, how wonderful. So these are the type sites we recommend. Any questions? Again, I implore you, let the teachers get to it first. Please, we appreciate your support, but they will be doing this a lot slower. You may not understand all of this 100%, but you could help your child. And if you don't know what they're doing, ask them, what do you think it means? What would you do? And if they really don't have an answer, the teacher wants to know that. It's better not to help them get through it, because then we don't know to help them in class. Okay, thank you very much.
Thank you.